And we're live.
Don't drop the soap.
Don't drop the soap.
Don't
What?
drop the soap. You said soapbox.
Oh, jeez. Hello, ladies. That was Drew Fangman over there. Hope you're having a great time there in Louisville, Kentucky. And, of course, Drew just said don't drop the soap. But anyway, that would be Drew for you.
Why would you say they're in Kentucky when they're going to be watching this? They're going to be here?
I don't know. They're going to get it on YouTube so they can see it at any time.
I really don't think they're going to watch it while they're at FFA.
Well, you know what? They can, so if they don't, that's their own prerogative.
I was wondering why you're coming back here. I'm like, are you going to turn it off? What's going on here?
So, all right, from the activity that we had, nuts and bolts the other day, I think we were starting to define what some of those particular dishes were in terms of some of these terms that we had here. Okay, so I can't remember quite all the dishes that we had. Hopefully you got the information in front of you specifically. I can bring the dishes up front with me that we can look at while we're jotting some stuff down up here. So with that being said, what did you guys have listed for characteristics for some of your dishes? For like what groups they were put in?
Color.
Color.
Shape.
Shape. Seemed like we were focusing on something else.
Wasn't like
If they're
how
connected
many-
or not connected.
Okay. If they're connected versus not connected. Give you an example here. This is dish number 6. It contains a nut and a bolt that are connected. So a nut and a bolt that are connected. So is there any word in here that looks like it tells you that you should have some things that are connected?
No, I think it'd be a compound, wouldn't it?
Can you give me an example of how you'd use the word compound? Like say in the English, like say like an English
compound
class.
word.
A compound word. What's that mean?
It's like do and not to don't.
Okay, so you're bringing two words together. Okay, so like the nut, huh?
That's correct.
It is, but okay.
Actually, what
But
was
the
it?
idea is you have
God.
two words that are put together,
You ruined all my jokes.
as in a compound sentence. Yeah, it's like right here, the nut and the bolt you have put together. So that would be what a compound is. Two or more substances put together. Two or more substances put together. Bless you. Okay. Now, in dish six, these were the only things that were in it. Okay. Obviously there wasn't anything else in it other than these two nuts and bolts that were put together. They're both alike. How does that differ from, say, something like dish 9?
It's just a random
It's miscellaneous.
stuff.
Miscellaneous, yeah. So this is all miscellaneous. Whereas this here is one type of thing, one type of substance. That's what we call a pure substance. It's one type of substance. One type of substance only. Okay. Did we have other examples where we just had one type of substance in a dish?
Just one.
Yeah.
The washers. Time washer thingies.
Yeah, the washer thingies. It's like dish 2 had one kind of washer. Dish 4 had kind of like a screw nut. Dish 5 had some interesting looking washers.
Lock washers.
Huh?
Lock washers.
Lock washers, okay. But they are all only one type of substance. What's the difference between something like dish 2 compared to dish 6? What's the difference between
One's a
two?
compound and one's a pure substance.
Well, This is only one type of thing. This is only one type of thing.
But there's two things in that one thing
Ah, two things that are what?
put together.
Put together. And this is just
Itself.
itself, one thing. So we can break up substances into two types of pure substances. We have elements and compounds. A compound is two or more substances put together. An element is only one, we're going to call atom, or one type of atom by itself. One type of atom. So we know that everything is made up of atoms. So I can never trust an atom.
Wouldn't it be funny if your name was actually Adam?
My brother-in-law's name is Adam.
You don't trust your brother-in-law?
I never said that.
Well, you said never trust an Adam.
They make up everything.
Well, that means you're telling me that your stepbrother lies a lot.
No, he doesn't.
Either that or he's really good at making up stories to tell kids.
Anyway. So a pure substance is one type of substance. An element's one type of atom by itself. So then a compound then, by that definition, would be two or more atoms. I should say two or more different types of atoms put together. Because in 6 here we have two different types of atoms. We have a nut and a bolt, two different kinds of atoms. Here we have in dish 2 only one type of atom, washers. So an element is one type of atom by itself. A compound is two or more different types of atoms put together. Okay? Now, a mixture. All right, number 9, you guys are starting to call that a mixture already. Okay? So number 9 we could clarify very easily as a mixture. All right, well, if you want to grab the video cam, I'll re-show you what I was showing you a couple of days ago on Tuesday. With the, let's see, if you want to grab it, and I'll show you guys sulfur, iron filings. Okay, sulfur and iron. They are two elements. Okay, put them together. Kyle, you want to grab that glass mixer deal over by the sulfur? Now, you guys saw this from the other day, but just a friendly
Yeah,
reminder.
they using the same stuff as last time or new stuff?
Yes. This is that same stuff, but again, wanting to make sure that just a refresher for you guys, and obviously the ladies can see it there as well. Now, would this be an example
Mixture.
of a mixture or a pure substance? And if so, if it's a pure substance, what kind? So, mixture, Kyle?
It'd be a mixture
Why?
because it hasn't properly formed together. It's just two mixed objects in one little bowl.
Okay. And plus, I'm able to take out the iron filings by itself.
I think you need a bigger magnet.
Yeah, probably.
You could just have like a mega magnet and just put it down to 6 everything.
Yeah, that'd be kind of nice. tractor beam? Like a tractor beam on the Death Star?
Look, guys, I got a furry tractor.
What?
No, you don't know.
No, I know.
If you don't know, now you know.
What's that one from?
Anchorman.
Okay, I think, okay. It's been a while since I've seen that movie.
Is it really?
Yeah.
What part?
Oh, boy.
But he's riding the bear.
And what's that from?
His mouth.
You know, that's from a movie.
That noise?
Yep. What Andrew just did.
What's awful?
RoboCop.
Trying to think. The character's name is Hannibal Lecter.
Silence of the Lambs.
Thank you. Silence of the Lambs. Yep.
I just went with some camp to Papa Beans of the Night.
So now we have them separated again, the sulfur and the iron filings, and we were able to do that with a magnet. Okay, so what did I just use? I mean, I know I used a magnet, but what can we say about a mixture that wouldn't be true about a compound?
You can take it apart.
Okay, take it apart based on what?
Magnets.
Yeah. Or, so I can take mixtures apart. I'm just going to make that statement right now. So you can take apart, and we'll add some more information to that in a moment. Now, I promised you guys that I would try to, let's see.
Fire.
Yeah, I promised you guys that. Do you know where do you know where the switch is at in the science room to turn it on?
No, you want to show me? I know.
I'll get it. I'll be right back. One of you guys want to pull up the door cover for the fume hood, and we'll do a little fire action here in a moment.
Fire action. Well,
I can't find him doing that fun scene.
tell you this is a lie.
Where's the hood?
What?
Word of hood, word of hood, word of hood.
The whole thing right there?
Which one are we doing? There.
The one that has a hood?
That's why this movie is cold. Yeah, please, if you could, just set them anywhere on the left tables.
Found it.
No, he didn't.
What, Hannibal Lecter? Yeah, you did. Yes, you did.
It's cranking the full.
Yes, it is. Again, the reason why this is... Okay, Drew, that's 20. That's enough.
I did want to see it.
Oh!
Jeez.
Alright, where's the sulfur iron mixture at?
Right there, Kyle, get it to him.
Alright. Got here. Bring the other thing with you, because that's what I'm actually going to need. So you want to dump it in there. Gather around, fellas.
Gather around the campfire.
Thank you. There we go.
Oh, that's toast.
In the back, someone want to grab me a pair of goggles, please.
I will.
Safety first.
There you go.
So obviously you
I
want
have
to
safety
stick,
glasses. Do those count?
huh?
I have safety glasses.
Well, I meant for me because I'm directly going to be reacting to chemical, and I'll put this splash guard down a little bit so that way we should be all right.
Nice and deep, like.
Everyone around campfire.
About the
Ready? Thank you.
Did you get new goggles?
Yeah. Thank you. That's right.
No, something's happening. It's melting.
It's turning blue.
Put the camera right
Oh, it's gonna start stinking here really bad. That's why I turned that on. Okay, check this out. You can start to see a little bit of a brownish flame. See that? Or a little bit of brown coming out there.
It's in the like very bottom of it.
Wait, looks like it's part of the shadow.
I watched another High School Life.
I like how Marshall like.
Okay, let's call that good. Good enough. I meant to turn that off. Okay. Oh. Yeah. Let's leave that going.
Whoa, whoa. Magic fire! It's gonna burn the whole house.
It'll be fine. Can you do that? Alright, we're gonna leave that go for a moment. Alright. Let's head back to our seats. We'll wait for that to cool off.
The tongue. Those are tongues, those are hemostats.
Sorry.
No. Those are not hemostats. I can't
Alright,
see.
here's where I need you, Hunter.
I can't see this. On board. Ah. Hey, we're doing goofy.
Okay, so over here I've got
Missing something.
water and ethanol.
And
Tell me what you know about them.
ethanol
They're
will flow on
liquids.
water.
Huh?
Ethanol is lighter than water.
How do you know that?
Because we did this in physical science and ethanol flows.
Okay. So,
Less dense.
huh?
Less dense.
So it's less dense. Okay, so up there, I want you to write down density for the property on the table. There's a table over there. Got up there already. So density. Water is 1.0. And ethanol is 0.8. Remember your units for it? Units of density?
Milliliters per grams per milliliter.
Grams per milliliter. Yep, grams per milliliter. Okay. All right. What else do you know is different about ethanol and water?
It's not water.
Okay.
Ethanol lights on fire.
So property, flammability.
Yes.
We're gonna light it on top of the water.
What?
So ethanol, you're saying is flammable or not flammable?
Flammable.
Flammable. So do you want to put like yes for ethanol? What about for water? No.
This wisecracker.
Okay.
I've got the burn events.
David, you were saying something else about ethanol and water. Or someone else was saying something different about ethanol and water.
Which spelled different.
Smell. So smell would be another property. So ethanol has an odor, water does not.
No odor. Yes.
Yep. Okay. Anything else that you know about these guys?
I would assume it would taste different.
No, we wouldn't want to taste them. But obviously the odor
You don't want to
is
taste
more or
water?
less kind of the taste thing too, huh? True.
Mac, wait, Mr. No.
What about from last unit? What were two properties that we dealt with water in last unit?
Freezing temperature and boiling.
Ah, so the melting point and the boiling point. So melting point is one property. So MP and BP.
BP ethanol.
What's the melting point of water?
What? For the water.
Melting point of water.
Anything above 32 degrees.
Celsius, gang, Celsius.
Anything above 0.
0 degrees Celsius. Not anything above 0, 0 itself.
But if it's at 0, isn't it freezing?
But if it's at 0, you can start melting it. That's one of the big things that I noticed on the test. People were having things melt above 0 degrees.
They do melt.
It melts at 0 degrees. Once it's above 0 degrees, it's completely melted. Okay, boiling point, what do we know about water?
100.
100.
100.
Kyle, you want to check to see if that thing's still on fire?
That thing is not still on fire.
Okay, do me a favor, shut off the fume hood. Thank you. Okay, now for ethanol. Ethanol has a melting point of negative 117
Celsius.
Celsius.
Let's freeze ethanol. Wow, that would be hard.
And then the boiling point
That would be really hard.
is 80 degrees Celsius.
Boiling?
Boiling point is 80 degrees Celsius.
Wow.
Okay, so with that being said, oh, I need some sugar.
Oh, sugar.
Alright, well, I got one in there, I guess already.
Sugar alcohol. Ooh, sugar and alcohol. Sugar and alcohol. Wow.
Okay, here's sugar for the one test tube. Sugar for the other.
Riddle me this. What's the difference between what?
What'd you say, Kyle?
What's the difference between a vial and a test tube?
A vial and a test tube?
Yeah.
A vial is generally something that you can put like a cap on top of. A test tube, not quite the case. And usually vials are a little bit bigger, a little wider.
Wow. The more you know.
Okay, now, let's try this. Ethanol and sugar.
It ain't mixing. It doesn't like what?
Water and sugar.
Water was big old jugs. And a big old jug.
Hey, want it to be noticeable.
He's dead. The more you know.
Who's dead?
Baby small.
Did not know that.
No, he's just hiding, like Tupac.
Too bad.
Tupacs.
Too bad.
Tupacs.
If I were to choose one, I would choose baby.
Let's add some more.
He died on a birthday.
Happy birthday, Kyle.
That's probably your fault then.
Kyle never said he'd rather have Biggie alive than me.
Okay, well, as you're starting to see and notice here, granted I probably don't have enough water in it, but what's going on with the sugar in the water?
Dissolve.
It's dissolving. Okay, that's another property. We call that solubility, Hunter.
How do you spell that?
S-O-L.
Hummingbird food.
S-O-L.
U-B.
What is hummingbird food?
Sugar water.
I-L.
Coloring.
Dyed red.
I-T-Y.
Can anyone see red?
Well, there
Solubility.
Put it in my mouth.
Okay, so solubility with sugar. What can we say about sugar and water?
Dissolves.
Sinks. And then dissolves.
There's sugar.
Yeah.
Hummingbirds drink it.
Now, obviously, it takes so much water to dissolve it, but it will dissolve.
Wow.
Okay?
Takes 15 minutes to absorb 8 hours.
What does sugar?
No, your body.
6 minutes?
15.
To absorb water?
To absorb 8?
Okay, another test tube.
Oh, because why would you drink it? It's absorbed.
Water.
Just sits in your belly. So you just
Your
sit
belly
there.
absorbed it.
Kyle, you were telling me about this already, I think. Or maybe it was David. I'm trying to remember who.
I think it's Drew.
Or Drew.
No, it's not.
Water, sugar.
Water and
sugar? What's water and sugar?
No, water and alcohol, the ethanol.
I can't see it.
Well, come on up. Take a peek. Now, let's try putting the sugar in.
No! Oh, okay.
Yeah.
We need to put that in the fume hood right now.
Where's the end come from? I didn't get to see it without the ethyl alcohol. Where's the end come from?
Now, what do you notice about it compared to the other stuff here? Come on close. Come on up. Yo, get closer. What do you notice about this stuff compared to the sugar water?
The sugars aren't dissolving. It's just floating around.
I would drink it.
Why not? Why is it not completely dissolving?
Because
It
there's
doesn't agree
alcohol.
with the others.
Yeah, the alcohol doesn't agree. Yep, exactly. Now, how could we go about if I wanted to separate this? How would I go about separating this or trying to separate this?
Evaporate it.
Okay, evaporate it, or you're saying burn it, but instead of just burning it, so that way I could try to get the ethanol back, how could I do that?
Boil it.
Filtration.
Boil
Put a
it.
firecracker in it.
Boil it.
What?
So in other words, I'm separating the substances based on their. Put it down. Separating them based on the boiling point, aka their properties. So in here, I can separate out. The sugar and the water and the alcohol based on the boiling point. So I can separate those out based on the boiling point. I think that's actually about everything.
The more you learn.
Do you and Justin plan to wear that sweatshirt on the same days?
Is he wearing it today?
Yeah.
Good for him.
Good for him.
Oh, one other thing. Then sodium chloride. Here, and water.
A lot of water.
Mm-hmm.
Where's the sodium chloride at?
It's in that big green container.
Oh. That's salt. Wow. Never would have known.
Did you know you're not supposed to eat salt after you work out?
Why?
Because all the water in your body's like, we gotta go to the salt. So it does go to your muscles. It goes to
Or
the
should
salt.
you eat just salt? Like pure salt?
Wow.
Awful idea.
Well, why do you think why do they think it's a good thing to have Gatorade while you're working out, or at
Because
least a
it
little bit of it?
contains the water in your body.
And what else?
Electrolytes.
Tasty!
AKA
Sodium chloride.
Sodium
It
Yeah.
only doesn't quench your thirst, but it tastes good too.
yeah. So anyway, now if I wanted to separate out this saltwater mixture, what would I do?
Burn it.
Evaporate.
I would boil it. I can't burn it; it's not gonna do any good.
Why did you
Thank
put
God,
the
dude.
Water's not flammable,
I don't know.
so yeah, I'd boil that.
Pour gas.
like burning everything?
Pour gas.
right?
It's flammable.
Burn it.
Put oil in it. It'll burn.
Oh, but I could touch
Water?
it.
Is that how you take your clothes off? You just burn them off?
Yeah.
I'm
Did you drop Taylor's phone on your face yesterday?
Why don't you just film it, Drew?
Sand.
Oh, no.
Sand in the place where you live.
Now, all of these substances I have here, would you classify these as mixtures or as pure substances?
Mixtures.
Mixtures.
Okay, and why?
These are not pure substances.
Okay. Why are they not compounds?
Because they
Because
can
you
be
didn't, you
separated.
didn't ask if they were compounds.
No, they're not compounds.
Could they be compounds?
Could be, I
They
guess.
could be if
The water and the sugar could be.
If you took the atoms and threw them together.
Okay, what did I do over there to combine them?
Mix-
melted them.
Or whatever, yeah.
it's a solution.
Well, I melted them by doing, what was I applying to it?
Fire.
Heat.
Applying heat to it. But if I apply heat to salt water, what do I know is going to happen?
Nothing.
It's gonna boil it.
It's going to boil it, so what's going to happen to the water?
The salt will separate from the water.
Exactly, salt's going to separate from the water. So these guys did not chemically combine. I can separate these substances based on their properties. Compounds I cannot. Okay? So now, of the substances that I have here, these are both mixtures. What's different about them?
Well, you see, the sand doesn't give
The sand what?
it.
Isn't going to what?
the left?
Not dissolving.
It didn't dissolve. Okay?
The one
Whereas this one did.
that way.
So now we have our two types of mixtures. Okay, I'm going to head to the board.
Two
Couple
types of
last
mixtures.
notes.
We're going back to our feet now. Our feet.
Don't worry about that, we'll get it later. So mixtures you can take apart based on their properties. So we have two kinds of mixtures. What's called homogeneous and heterogeneous.
You did?
You broke his magnet, Drew?
How?
So homogeneous, which one of those do you think would be homogeneous?
The sand. No.
Look at the two.
Homo means same.
Homo means same. Okay, so the homogeneous, that would be a substance where one is dissolved in another. Heterogeneous, you can see the different substances in the mixture.
Yes.
Okay? There's your difference. Substance, you've got homogeneous substance where one is dissolved in another. You can't see the different parts. Heterogeneous, you can see the different substances in the mixture. But a mixture itself is something that you can take apart based on their properties. They are not combined chemically. Whereas a compound is. There are two or more atoms of a different type put together chemically. And we'll call it good with that.
Yes.
Science.
All right, if you want to hit
yeah.
stop on the camera, please.
Oh, I got it.
Ah, you hit the wrong button. No.
Is it the red one?
No.